Three integrals from our previous test. Number 1, 5x to the fourth minus 3e to the negative 0.8x plus 8 dx. You need to know all your forms of integrals. They're going to come up in here. So if you're not sure of all the actual formulas for integrals, review those. And number 3 will require substitution. Stop the video, perform the integrals now, and then after you've hit pause, then go ahead and hit play, and let's work through them. Okay, a constant just comes along. This one is x to the fourth. The rule for integrals x to the n plus 1. 4 plus 1 is 5, divided by 5. We'll reduce in a moment. Minus 3 times e to the ax, the integral formula for that, with a being negative 0.8, is that e to the ax over a, so negative 0.8 is on the bottom. We'll reduce that in a moment. Plus 8, a constant's integral, plus 8x, plus another constant c. Finish, you can reduce if you want. But as far as integration, we have completed it. Reduce would be x to the fifth, whatever, negative 3 divided by negative 0.8 is. Use your calculator to reduce that. 3 over 0.8 e to the negative 0.8x plus 8x plus c. Number 2, we don't have any rules with square root, much less anything with square root on the bottom. So we're going to rewrite 2 times x. A square root is 1/2 power. Something on the bottom moves to the top as a negative power. So 2 times x to the negative 1/2. Plus 1.2 to the x dx. Okay, answer is 2 comes along. Same rule applies to x to the negative 1/2 that applied to x to the fourth. You add 1, which gives you 1/2 divided by 1/2, which is multiplying by 2. Plus, this is b to the x. It's not e to anything. It's another base b. So we know the rule, or we should look it up. 1.2 to the x over natural log of 1.2 plus a constant, and we're finished. 2 times 2 is 4. You could reduce that, obviously. Number 3 is a level more complex. We need to do a substitution. This is a multiplication or a product, f times g. There is no rule f times g. I saw this on a number of tests, and I mentioned this beforehand, that this is not integral of f times integral of g dx. You cannot integrate pieces of that. No rule. Get a tattoo of that on your forearm so you don't do that on any future calculus test. We have to find a substitution that'll work. This thing inside the square root is also a problem because there's no chain rule for integrals as well as no product rule. So I'm going to let u equal 5x cubed plus 8. du would be 15x squared dx. I don't have 15x squared, I have 2x squared. Not any kind of problem. I come down here and rewrite my integral. Okay, let's take the 2 outside. I need to have 15x squared. So the 2's gone. I just inserted a 15, so I'm going to put 1 on the bottom. 15 over 15 is 1. That's no change to the problem. Times the square root of 5x cubed plus 8 dx. In this form, we can see the substitution quite clearly. I'm going to move over here due to the lack of visual space much lower. So 2 over 15 times the integral of, let's see, that is actually u. So I have u to the 1/2 power. 15x squared dx is precisely du. So I have u to the 1/2 du, and nearing an answer now very quickly. 2 to the 15th, add 1, u to the 3/2, divide by 3/2 is the same as multiplying by 2/3. So the rule is u to the n plus 1 over n plus 1. N plus 1 is 3/2. We multiply by the reciprocal in order to do that. So substitute your u's back into x's. That's 5x cubed plus 3, plus 8 rather, to the 3/2 power. And we might as well multiply that out and get 4 over 45. Plus a constant. Probably should have put a plus c over here as well, but we definitely should have it on our final answer. Okay, so that's the first 3 problems from the test.